Hello students, welcome to all of you in SAM Alchemy classes. In class 12th, Unit 10, Haloalkanes and haloarenes, preparations is completed. Now physical properties. We have discussed about preparation of haloalkanes, that is alkyl halides, in previous segments. So today we will discuss about physical properties of alkyl halides. So first of all, about nature of alkyl halides. What about the nature of alkyl halides? These are polar in nature. Polar in nature. ये polar होते हैं. What means are polar? CX bond due to greater electronegativity of halogen than electronegativity of carbon. The electron cloud partially shifted towards halogen, due to which halogen has partial negative charge while carbon has partial positive charge. So polarity is introduced. So this covalent bond of CX is polar in nature. But after polarity, it is insoluble in water. Although CX bond is polar in nature, yet these alkyl halides are insoluble in water. Water में insoluble होते हैं because interaction between alkyl halide and water, the bond dissociation energy is less than hydrogen bonds. What it means? Since we know hydrogen have intermolecular hydrogen bonding, and intermolecular hydrogen bonding is much stronger than the interaction between alkyl halide and water, so bond dissociation energy of hydrogen bonds is greater than the bond dissociation energy of the attraction between the alkyl halides and water. That's why these alkyl halides are insoluble in water. In simple language, we can say, since if alkyl halide need to dissolve in water, then some of intermolecular hydrogen bond must be break, and the bond dissociation of hydrogen bonding is greater. That's why alkyl halides are insoluble in water. In more simple language, why alkyl halides are insoluble in water, although these are polar in nature? It is only due to the absence of hydrogen bonding in alkyl halides. Between alkyl halides and water, alkyl halides are insoluble in water. In very simple language, it is due to absence of hydrogen bonding between alkyl halide and water. Alkyl halides are insoluble in water. So where alkyl halides are soluble? Alkyl halides are soluble in organic solvents. Organic solvents में ये soluble होते हैं alkyl halides, like carbon tetrachloride, like chloroform, like other organic components, उसमें etc. उन सब में क्या होते हैं? ये soluble होते हैं. So alkyl halides are insoluble in water while soluble in organic solvents. Next, after solubility, BP, boiling points. Boiling points depends on alkyl attached with halogen. Halogen पर भी डिपेंड करता है, alkyl पर भी डिपेंड करता है. Boiling point of alkyl halide depends on both alkyl and halogens. Here, van der Waals forces increases along with size of alkyl. size of alkyl and halogens. हैलोजेंस एंड एल्किल्स के साइज इंक्रीज करने के साथ साथ वांडरवाल फोर्सेस ऑफ अट्रैक्शन इंक्रीज करते हैं. वांडरवाल फोर्सेस ऑफ अट्रैक्शन आल्सो इंक्रीजेस along with surface area. Higher the surface area, higher will be van der Waal forces of attraction. And these van der Waal forces are inverse of side chain. साइड चेन के इन्वर्स होते हैं बिकॉज साइड चेन बढ़ने से वांडर वाल फोर्सेस कम होते जाएंगे बिकॉज सरफेस एरिया कम होता जाएगा. सो वांडर वाल फोर्सेस आर डायरेक्टली प्रोपोर्शनल टू साइज ऑफ एल्किल and size of halogen and surface area, and inversely proportional to side chain. Higher the side chain means branching in the alkyl, lower will be van der Waal forces, lower will be surface area. How it happens? So first we will take a fixed number of alkyl like methyl with different types of halogens like CH3F, CH3Cl, CH3Br and CH3I. So here this will be increasing order of boiling point. This is increasing order of boiling point. Increasing order of BP. How it happens? Because I minus is greater than in size with Br minus is greater than Cl minus is greater than F minus. This is the decreasing order of size. Decreasing order of size. So highest size is of iodide. So highest BP will be of CH3I. Is it clear? Here number of carbon for alkyl attached is fixed. So different halogens are attached with different sizes. Higher the size of halide, higher the size of halide, higher will be van der Waal forces that raises boiling point of alkyl halides. And if now we change the size of alkyl, then the order will be like this: CH3Cl, fixed halogen, C2H5Cl, C3H7Cl, C4H9Cl. Different sizes of alkyl attached. This is methyl, smallest size. C2H5 greater to methyl, C3H7 greater to ethyl, and C4H9 greater to or higher to this propyl. So this is less than this and this. This is increasing order. Increasing order of BP. How it happens? Because CH3, it has less molecular weight than C2H5, less molecular weight than C3H7, and less than C4H9. So this is the increasing order of size. Increasing order of size, or we can say increasing order of molecular weight. अगर molecular weight increase कर रहा है, so there is gradual increase in molecular weight from methyl to butyl. That's why there is gradual increase in the boiling points of alkyl halides. Since here halogen is fixed, but the difference in the boiling point is only due to the number of carbon attached, due to which size of alkyl increases and increase in molecular weight also carried out. That's why there is increase in the BP of alkyl halides. Now if molecular weight is same and size is different, let's take another example. If molecular weight is same or equal, but surface area is different. सरफेस एरिया इज डिफरेंट। अगर हम मॉलिक्यूलर वेट को सेम करें और सरफेस एरिया डिफरेंट हो, then how it happens and how the BP changes. Normal structure of an organic compound is greater with surface area than iso is greater in surface area than neo. Means higher the branching, surface area decreases. So here this is normal greater than iso greater than neo. This is decrease in surface area. Decrease in surface area. It means higher surface area will be of normal straight chain and least surface area will be of neo. For example, if we take isomeric alkyl halide of C4H9, this is butyl. So butyl, we can draw the structures CH3, CH2, 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 this. This is called normal butyl. This is normal butyl. Next isomeric form CH3, CHCH3, CH2. This is called isobutyl. Third one CH3, 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 this, and this is called neobutyl. So this is first case A, this is B, and this is C. As we know, along with branching, surface area decreases. So A greater than B is greater than C. This will be the decreasing order. Decreasing order of surface area. Decreasing order of surface area. A has maximum surface area, so order will be, since surface area is directly proportional to van der Waals forces, is directly proportional to boiling point. What it means? Higher the surface area, higher will be van der Waals forces of attraction that raises the boiling point of compound. Since in the isomeric form of butyl, normal, iso and neo is considered. Normal due to straight without branching has maximum surface area, and neo due to maximum branching has least surface area. That's why van der Waals forces of attraction will be maximum in normal and least will be neo. So this will be the order of boiling point for isomeric halogens. This A will be greater than B greater than C, means what? Normal greater than iso greater than neo. So this is all about related to boiling point of alkyl halides, making the different types of halogens attached and different types of in the case of sizes of alkyls, and if the molecular weight is same, then different surface area. So we have discussed all about related to BP of alkyl halides. Next is generally lower members of alkyl halides, like lower members like CH3Cl, C2H5Br, CH3I, etc. Lower members are gases. These are gases, while higher members are liquid and then after solid. These are generally colorless. These are colorless in nature. Colorless. While bromide and iodide exposed, when exposed in air, imparts color, gives color. सिर्फ ब्रोमाइड एंड आयोडाइड ऐसे हैं जब वो एयर में एक्सपोज होते हैं देन वो कुछ कलर डेवलप करते हैं, बाकी जो इनके हाइलाइट्स हैं वो सभी कलरलेस होते हैं इन नॉर्मल कंडीशन. नेक्स्ट इज chemical properties of alkyl halides. Next is chemical properties. Chemical properties में first of all, due to CX bond nature, shifting of these electron cloud towards more electronegative halogen, it has some negative charge partially and carbon has some partial positive charge. Due to this polarity, these alkyl halides undergoes nucleophilic substitution reactions. Characteristic nucleophilic substitution reactions are represented by alkyl halides where nucleophile, suppose nucleophile is A negative, displaces this X and formation of Ca with X minus takes place. So this is a type of nucleophilic substitution. In previous segments we have discussed in detail. Whenever attacking reagent is a nucleophile that displaces another nucleophile from substrate, this displacement or substitution is referred as nucleophilic substitution. And alkyl halides, haloalkanes represents characteristic nucleophilic substitution reactions and these are represented by SN carried out in two ways, SN1 and SN2. We will discuss later in this chapter. So first of all, the characteristic reactions of alkyl halide and these are substitution reaction. Substitution reaction. Since we know substitution is carried out by a nucleophile, so nucleophilic substitution को हम डिस्कस करेंगे. न्यूक्लियोफिलिक्स टू कैटेगरी के होते हैं, हम इसको डिस्कस कर चुके हैं. निगेटिव चार्ज एंड न्यूट्रल. इन निगेटिव चार्ज लाइक OH minus, like RCOO minus, like RO minus. Here in neutral, like ammonia due to electron density, like primary amine RNH2. These are neutral electrophiles that displaces another nucleophile. So first, in nucleophilic substitution, very important reaction. First, reaction with KOH, condition aqueous KOH must be noted. एक्वस की कंडीशन चेंज होगी और इसी चैप्टर में डिस्कस करेंगे. अगर वो अल्कोहलिक होगी देन रिएक्शन हो जाएगी इलिमिनेशन, नॉट सब्स्टिट्यूशन. सो एक्वा इज मस्ट. व्हेनेवर alkyl halide reacts with KOH and condition aqueous KOH, then since we know there is partial negative charge at halogen, partial positive charge at carbon, so this negative charge OH displaces this halide, formation of ROH with elimination of KX. So this alkyl halide converts into alcohol. This reaction is related to preparation of alcohols from alkyl halides. नेक्स्ट इसके बाद के चैप्टर्स में अल्कोहल फिनॉल ईथर में प्रिपरेशन ऑफ अल्कोहल्स में फिर ये रिएक्शन आएगी, प्रिपरेशन ऑफ अल्कोहल्स फ्रॉम एल्किल हैलाइड्स. सो दिस इज अ कैटेगरी ऑफ न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन. सो नाउ रियल एग्जांपल, CH3Br reacts with KOH, condition aqueous. Now KBr as byproduct, and formation of this OH displaces Br, formation of CH3OH, methanol is formed. Methanol, CH3OH is formed. Next is C2H5Cl reacts with KOH condition aqueous. Now OH releases this formation of C2H5OH plus KCl. Ethanol is formed. The mechanism we have discussed already, nucleophilic substitution, but we'll discuss later on in this chapter whenever SN1 and SN2 will be discussed in detail. Next, what will be reactivity order? The reactivity order will be iodide greater than bromide greater than chloride greater than fluoride. It is due to decrease in size. Decrease in size, reactivity decreases because bond length decreases. Here larger bond length, so lower bond dissociation energy is required. Increase in bond dissociation energy. बॉन्ड डिसोसिएशन एनर्जी बढ़ती जाएगी, दैट्स वाई रिएक्टिविटी डिक्रीज होती जाएगी, क्योंकि यहाँ पर साइज डिक्रीज होता जा रहा है. ये भी कह सकते हैं डिक्रीज इन बॉन्ड लेंथ. So now, due to decrease in bond length from iodide to fluoride, their bond dissociation energy increases. Decrease in bond length, bond dissociation energy increases. It is tough to break the short bond as compared to long bond. And reactivity also decreases because bond size decreases, so bond dissociation energy increases, so its reactivity decreases and size decreases. So this is the order for the reactivity and size of halide attached. So now what will be the order of alkyl? In alkyl, tertiary will be greater than secondary, will be greater than primary, will be greater than methyl. How? Just see here, CH3, CH2, 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 Br. Next is CH3, CH, Br, CH3, CH3. So here and next is CH3, CH2, CH, Br, CH3. This is first A, this is B, and this is C. Here the isomeric form of alkyl halide is given, and this is C4H9Br. These are three isomeric form of the C4H9Br. Here primary, this is primary carbon. Here tertiary, this is tertiary carbon, and here secondary, CHBr, this is secondary. A, B, C, primary, tertiary and secondary. What is the order of reactivity? Tertiary reacts very fast with aqueous KOH, then secondary, then primary. So what will be the order? B greater than C greater than A. This is decreasing order of reactivity. Decreasing order of reactivity with KOH aqua. This will be the order. The tertiary halide will react very fast than secondary, and secondary reacts very fast than primary. So this will be the order of reactivity among isomeric primary, secondary and tertiary. Next, in place of KOH aqueous, we can take moist silver. Moist silver is AgOH. This is called moist silver. If this moist silver is heated strongly, then it gives Ag2O with elimination of water. This is called dry silver. So remember, what is the difference between moist silver and dry silver? The formula of moist silver will be AgOH and of dry silver will be Ag2O. Here we will discuss about moist silver. In moist silver, Rx reacts with AgOH. The reaction goes on in same pattern AgX because OH minus displaces this formation of ROH with elimination of AgX silver halide. Again alcohol is formed. So taking real example, CH3Br reacts with AgOH and this is moist silver. Now formation of CH3OH with elimination of AgBr, alcohol methanol will be formed. यहाँ पर हमने मॉइस्ट सिल्वर से रिएक्शन को डिस्कस किया है, नोट करके कॉम्पिटिटिव अप्रोच के लिए अलग से आप पढ़ सकते हैं. रिएक्शन विद ड्राई सिल्वर, रिएक्शन विद ड्राई सिल्वर, ये रिएक्शन न्यूक्लियोफिलिक सब्स्टिट्यूशन का पार्ट नहीं है, ये हम आपको अलग से कॉम्पिटिटिव अप्रोच के लिए बता रहे हैं. नाउ Rx रिएक्ट्स विद Ag2O, 2Ag, so 2x elimination of 2AgX with 2 alkyl and 1 oxygen, ROR, ether is formed, not alcohol. Whenever dry silver, this is dry silver. Whenever dry silver reacts with alkyl halide, then ether is formed as the main product, not alcohol. Like here C2H5 Br reacts with Ag2O. This is dry silver, formation of C2H5O C2H5 with elimination of AgBr, 2AgBr, 2C2H5Br. This is ethoxyethane. इसके रूल को नॉमेनक्लेचर के सेगमेंट में डिटेल में डिस्कस कर चुके हैं. दिस इज एथॉक्सीइथेन. नेक्स्ट, रिएक्शन विद सोडियम साल्ट ऑफ कार्बोक्सिलिक, सोडियम साल्ट ऑफ कार्बोक्सिलिक से अगर हम रिएक्शन करें कार्बोक्सिलिक एसिड से, तो प्रोडक्ट क्या बनेगा? लाइक RX alkyl halide reacts with RCOONA. This is silver salt of carboxylic. We can take both the R same or unidentical. Can identical or unidentical, same भी हो सकते हैं, different भी हो सकते हैं. Both the alkyl attached with halide, alkyl attached with carboxylic. Now here this Na reacts with X because RCOO minus displaces this X minus and formation of ROOCR dash. Remember, this alkyl carbon bond will not get break. This whole unit will comes in the form of this is minus, this is plus, this is minus, and this is plus. So this nucleophile displaces another nucleophile, nucleophilic substitution. This X minus and Na plus form NaX, sodium halide, and this alkyl R dash will be as such attached with carbon of carboxylic and comes in the form of ester. And here alkyl from alkyl halide will attach with the oxygen of the COO group. Alkyl halide will attach with the oxygen because we can note down this structure of ester like this. We can draw this structure. This is RCOO dash. Here R dash will be attached as such in the case of original parent carboxylic, but here in ester the alkyl shifted from alkyl halide will attach with the oxygen of this ester. So this ester is formed. How the real examples give the real products? Just take CH3Cl reacts with CH3COONA. The sodium acetate reacts with methyl chloride. The CH3COO minus displaces the Cl. Here CH3. This CH3 comes here. This CH3 comes here in this form. Now reacts attached with oxygen. Then C double bond or single bond, and this methyl comes here, this CH3. So we can note it in this way, CH3 COOCH3. नोमेनक्लेचर इसके नेम को डिस्कस कर चुके हैं डिटेल में. एल्किल एल्केनोएट. सो एल्किल इज मेथिल एंड एल्केनोएट ड्यूरिंग नेम ईस्टर के कार्बन को काउंट करते हैं. दिस इज एथ सिंगल बॉन्ड एन इथेनोएट इथेनोएट. सो नेम बिकम्स methyl ethanoate. Taking next with different alkyl attached with the carboxylic salt and alkyl halides, like here CH3Br reacts with C2H5COONA. Now the product form will be CH3OCOOC2H5 with elimination of NaBr. Or we can note it in this way, C2H5COOCH3. This methyl is attached with oxygen, so name will be methyl. And here C2H5C propanoate, propanoate. This will be the name methyl propanoate. Next is reaction with sodium alkoxide. Sodium alkoxide. What are sodium alkoxide? Like RONA, sodium alkoxy group, alkoxide. If R is methyl, then it is called sodium methoxide. Methoxide. If this is ethyl, then called sodium ethoxide. Now reacts with alkyl halides. So what the product is formed? Here RX. This is alkyl halide. Reacts with R-ONA. Both the R and R dash may be identical or may be unidentical, as in the case of carboxylic salts. Now this RO minus negative displaces another negative, means one nucleophile displaces another nucleophile. So it is again nucleophilic substitution reaction with elimination of NaX. Both the alkyl from alkyl halides and from oxide will be attached with the oxygen on the both the sides, and ether is formed and results ether like CH3Br reacts with C2H5ONA. This displaces bromide, formation of CH3OC2H5 with elimination of NaBr. and this is called methoxy. Less carbon containing is oxy. रूल्स पढ़ चुके nomenclature के segments में. Methoxy, and this is ethane. Higher carbon considered as parent chain. So methoxy ethane. Taking next example, like CH3 CH2 Br reacts with CH3 CH2 CH2 ONA, sodium propoxide. Here elimination of this Br, formation of C2H5O, CH2 CH2 CH3 with elimination of NaBr as byproduct. Now just see here, this is longest carbon chain probe and this is oxy group. So 1, 2, 3, its name will be 1-ethoxy. 1-ethoxy propane. This will be the name. इसके रूल्स को हम डिस्कस कर चुके हैं प्रीवियस सेगमेंट्स में. So in chemical properties we have today discussed about the nucleophilic substitution reactions. We will continue these reactions in next segment, and in this segment we have also discussed in detail about physical properties, their solubility, their CX bond nature, and how there is changes in the boiling points along with size of alkyl, along with size of halogens. So in detail we have discussed all. So we will continue the chemical properties of alkyl halides in next segment. Till then, students, thank you everybody.